Hello, I'm Andy Briggs, and welcome to the Amazing Astronomical Alphabet, a weekly programme in which my Astro Radio co-presenter Daz and I will be talking about anything astronomy related which begins with the week's letter of the alphabet. We'll each choose some things to talk about which are in some way related to the universe, but neither of us will know what the other has chosen. We will then reveal facts about them which are weird, strange, bizarre, or simply interesting. Well, welcome back, listeners, to the Amazing Astronomical Alphabet with me, Andy, and Daz. How are you, Daz?
I'm fine, thank you very much. It's very cold, very windy, and very wet.
How many degrees you got there at the moment?
Well, actually, the weather, the temperature, as I said, it's dropped, but it seems to keep climbing back up again in the evenings. So it's probably about 10 or 12 now. As the clouds roll in, it seems to warm up. So it's that global warming, I think.
Well, believe it or not, although this is Spain, we've got exactly the same. We've got 12 degrees and rain.
Oh.
And it's noticeably chilly. I actually had to put the heating on the other day for the first time since, I don't know, February.
Oh, getting the big coat out, are you?
Yeah, I went down into town today with a thick coat on, with an umbrella. And the only umbrella I could find was my daughter's Mickey Mouse umbrella. So I felt a right idiot, I can tell you.
Yeah, now I can see where they get mad dogs and Englishmen.
I began to wonder why people were staring at me, and I thought, there you are, a grown man with a Mickey Mouse umbrella.
Oh, bless, he's special.
But it did the job. It kept the rain off me.
That's all that matters.
That's how I don't care anything else. It just kept the rain off me.
Yeah, because when I used to do rallying and all that, when we weren't actually participating, we used to go and watch a lot of rallies. And of course, as you know, with the RAC in England, as it was in the old days, used to be in November. And of course, we used to walk into the forests, trudging a few miles, freezing cold and icicles off the ends of our nose or pouring the rain. And we'd be dressed like Michelin men with layers and waterproofs and everything and all that.
Yeah,
you get all these people who think they're the big boys, drive like idiots and think that they're the big I ams, going in their jeans and their designer trainers, all the girls in high heels and tight jeans, all freezing their gonads off. And we'll be sat there all nice, warm and toasty and all that. Well, they're sat there shivering, not enjoying one bit of it. So, as long as you're warm and dry, life's good.
Yeah, I had to walk down to the town yesterday in torrential rain to get my flu jab. So I wasn't in the best of humours when I arrived there, and they had
you probably got flu going.
Yeah, I probably did. And to make matters worse, the people hovering around the place where it was happening were all really really elderly people. Some were having to be helped along, And I thought, oh my God, please tell me I'm not like that. But there was a nurse supervising. Oh, thank you. Right, you're getting a booster.
Got me booster, yeah.
You got your booster coming in. They're not doing boosters here yet. Not for me, anyway. So there was a nurse supervising and a young man who was actually doing the injections. And after he'd given me the injection, she said to him the words that I really didn't want to hear. She said, "Well, you made a right mess of that, didn't you?" And I thought, what?
Yeah, he said an artery.
Yeah, I looked at my arm to see what he'd done, but he'd slapped a plaster on it by then, so I couldn't see. So,
oh dear me.
But I was really worried I might turn into a werewolf or something. But I used to be a werewolf, but I'm all right now. So
I was going to say, he probably didn't give you the flu jab. Probably gave you sort of like
anyway,
fertility drug.
Yeah. Anyway, no side effects. Luckily. So there you are. All right then, listeners, getting back to what we're here to do, the Amazing Astronomical Alphabet. We have reached the dizzy heights in the alphabet of the rectilinear T. So today we're going to be discussing things relating to the universe beginning with the letter T. And we'll also be playing some fab sounds and challenge you to guess the artist who will similarly begin with the letter T. So, Daz, I believe it's your turn to go first this week. So, over to you.
It certainly is. And T is for time domain astronomy.
Oh.
Now, people are probably asking, what is time domain astronomy? Well, what it actually is, time domain astronomy is the study of how astronomical objects change with time. Pretty obvious, actually.
Yeah, it is.
Though the study may be said to begin with Galileo's letters on sunspots. The term now refers especially to variable objects beyond the solar system. This may be due to movement or changes in the object itself. Common targets included are supernova, novas, flare stars, blazars, and active galactic nuclei. Visible light time domain studies include HAT South, the Large Synoptic Survey Telescope, Pan-STARRS, Sky Mapper, and Wide Angle Search for Planets, and the Catalina Real-Time Transient Survey. So that's basically some of the telescopes that they're using to study these in the optical. Time domain astronomy includes the study of transient astronomical events, often shortened by astronomers to transient. Astronomical objects or phenomena whose duration may be from milliseconds to days, weeks, or even several years. This is in contrast to the timescale of the millions or billions of years during which the galaxies and their component stars in our universe have evolved. Singularly, the term is used for violent deep sky events such as supernova, novae, dwarf nova outbursts, gamma ray bursts, and tidal disruption events, as well as gravitational microlensing, transient eclipses, and comets. There's also, not do they just do it optically, they use radio telescopes like LOFAR, which is looking at which looks at pulsars and scintillation. That's where things flicker. Then there's a whole array of telescopes again, which will be looking at transient events in X-ray and gamma rays. The gamma ray bursts are a well-known high-energy electromagnetic transient. Of course, they've been in the news quite recently, actually. But time domain astronomy uses robotic telescopes, automatic classification of transient events, and rapid notification of interested people. Blink comparators have long been used to detect differences between two photographic plates. The image subtraction became more used when digital photography eased the normalization of pairs of images. Time domain works involves storing and transferring a huge amount of data. This data includes mining techniques, classification, and handling of heterogeneous data. Historically, time domain astronomy has come to include appearances of comets and Cepheid variable. Old astronomical plates exposed from the 1880s through to the early 1990s, held by the Harvard College Observatory, are being digitized for this purpose. Other causes of time variability are asteroids, eclipses, microlensing, planetary transients, and variable stars. So basically, time domain astronomy is actually watching something change. And as it said, it can either happen in a few seconds, minutes, hours, days, weeks. It's basically what we can actually watch in our lifetime, in theory.
Yeah.
And it's basically how we learn how things go. We watch them, and then we'll find out what is actually going on. So that is what time domain astronomy is. So watching anything that is changing within the night sky.
Right. And as you mentioned, the Vera Rubin telescope, formerly known as the Large Synoptic Survey Telescope, or LSST, is going to image the whole of the southern sky every 3 days, which will enable them to see things that are changing over that period. And it's reckoned to make some major discoveries. I did read that for interested parties, they will be receiving immediate email notifications, and it's all an automated system. If the software detects any changes in objects, then it will fire out an email And I did read somewhere, and I find this actually very difficult to believe, that it could generate 1 million emails a night. And personally, I wouldn't fancy getting 1 million emails in my inbox. I'm sure that must have been a mistake, although who knows. So this is why time domain astronomy is so revolutionary. It's a revolution in astronomy, observing things on small scales in terms of time, and in short time intervals. So we could be looking at, anything changing. It could be an asteroid moving across the sky. It could be a nova. It could be, even satellites. Anything that changes in the night sky. The Vera Rubin telescope will in Chile will see it. And this is the whole new domain. The Vera Rubin telescope is not, however, due to start science operations now until 2023. It was meant to be next year, but it's been delayed by COVID. So it's doing its first observations in 2023. Incidentally, and I'm sure you know this, Daz, it will feature the world's biggest digital camera, which is the size of a car. And the lens in that camera is in the Guinness Book of Records for being the world's biggest camera lens.
Oh, okay.
1.7 meters across. It's the biggest single lens ever manufactured. It's quite a groundbreaking a piece of kit. Of course, that's not a lens as in a camera lens. It's just the glass between the receiver to focus the image, basically. So that will really be a telescope to watch out for. It promises to make many major discoveries in this whole field of time domain astronomy.
Yeah, I'll have to have a look at the Vera Rubin, see how big the actual light chip is.
Yeah, if you go to lsst.org, that's where you'll find everything. T is for, believe it or not, telescope. I mean, we couldn't do an astronomy series without telescope. But in particular, what I'd like to just tell our listeners about are the new generation of telescopes that are going online within the next few years. So I've just got a list here that I'll talk to you about. The Vera Rubin telescope is on the list, so that's one we can cross off. Not much more to say about that, really. The most immediate and pressing one, of course, is the James Webb Space Telescope, which is allegedly launching on December the 18th. And that date, the closer we get to it, looks fairly set in stone now. So the JWST is an infrared telescope. It's been billed as the successor to Hubble, but it's only the successor to Hubble in as much as it's the next big space telescope. It's completely different to Hubble because it is an infrared telescope, and infrared telescopes have the ability to peer into dust clouds, particularly to put them aside like they're not there, because we need a space telescope because infrared radiation is largely absorbed by our atmosphere. So we need a telescope outside the atmosphere to look in the infrared. So we'll be able to peer into nebulae and galaxy clusters, anywhere where there are huge clouds of dust, and see what's actually there. And it's a revolutionary telescope. Its construction is revolutionary, and everything about it is revolutionary. It's going to trail the Earth in its orbit about 1 million miles from the Earth, as we were talking about last night on Reach Out and Touch Space, with our lovely guest Natalie. And it's going to launch on December the 18th, but it's going to be next June before we start seeing images from it, because it takes a long time to commission and test everything. And the deployment sequence lasts for 2 weeks. So the 2 weeks over Christmas, after December the 18th, us followers of the project are going to have no fingernails left, because there are over 300 separate operations that the telescope has to carry out before it's fully deployed. And if any one of those goes wrong, the whole telescope costing billions will be essentially a pile of junk. We don't even want to think about that. We're not tempting fate,
Nope.
so we're not thinking about that. So there we are. So that's the James Webb Space Telescope, launched in the mid 2020s. In just a few years, we've got the launch of the Roman telescope, or to give it its full name, the Nancy Grace Roman Telescope. It was formerly called W-FIRST, which stood for the Wide Field Infrared Space Telescope. It's been renamed the Nancy Grace Roman Telescope after Nancy Grace Roman, who's seen as the mother of Hubble, who tirelessly pushed for astronomers to get better tools, especially in space, and it's named after her. She died in 2018, I believe.
Amazing woman she was, yeah.
Yeah, an amazing woman. So this telescope is going to be, again, at the same place as the James Webb Telescope. It's going to be at the L2 Lagrange point. It will be about 930,000 miles from Earth, just a little bit closer than the James Webb. You don't want them getting too close, of course. And it's going to, again, be an infrared telescope, but its primary mission is to search for clues to the origin and nature of dark matter and dark energy. So this is a different telescope, whereas the James Webb will have a range of different targets. The James Webb Space Telescope should be able to see the first galaxies in formation. It's going to look at directly image exoplanets, that is, planets orbiting other stars. But the Roman telescope will have specific goals of trying to work out what dark matter and dark energy are. And that's launching in the mid-2020s. They haven't set an exact launch date yet. Then we've got at Mauna Kea in Hawaii, we've got the 30-meter telescope. And this is going to do general astronomy. It's an optical telescope going to do general astronomy. And unfortunately, the whole project is stalled because native Hawaiians have objected to the presence of the telescope on Mauna Kea, which to them is a sacred mountain. And there have been lots of legal battles going on. The legal battle was won by the consortium behind the telescope. Construction was meant to start in 2019, but has yet to do so because of ongoing complications. And what the consortium may end up doing, in fact, is to go somewhere else. They may build it on the island of La Palma in the Canary Islands instead, where the skies aren't quite as dark nor as clear as they are in Hawaii, but it's the next best thing. La Palma, of course, at the moment has got additional problems because it has an erupting volcano, which nobody foresaw. And they've created on La Palma a sort of a forerunner of the 30-meter telescope, a Pathfinder telescope, and that has already begun detecting dust from the volcano. We're hoping that the volcano will quieten down soon. It only needs to go another, I think, 5 days in its eruption when it becomes the longest recorded eruption of that particular volcano on La Palma. The volcano erupts about once every 50 years. And a few days ago, it looked like it had quietened down. The seismic activity had quietened down, but now it's picked up again. And they had a 5.1, I think, earthquake yesterday. The biggest yet detected there at a depth of about 36 kilometers. So fairly deep, but there's something, scientists are a bit puzzled as to what's going on at that depth because they thought the magma chamber was beginning to empty, but the seismic activity would indicate that there's still something really active at that volcano. But if you haven't seen any of the videos on YouTube of the La Palma volcano, do look them up. It's tragic because over 2,000 buildings have been lost. Many people have lost their homes that have been engulfed by the lava. So it's a real human tragedy in the making. The banana plantations may lose about 60% of their crop. So it's all very tragic, but the images of the volcano are just absolutely stunning. So that's the 30-meter telescope. Don't know when it's going to be built. Don't know when it's going to be finished. Then we have another giant telescope in the next generation of telescopes, the aptly named Giant Magellan Telescope. It's going to have first light in 2029. It's being built in at the southern edge of Chile's Atacama Desert, which is the driest non-polar region in the world, believe it or not. It's the driest non-polar desert in the world. And it's a 24.5 meter telescope. And they claim that will be the most optically efficient of its class, the 30-meter class. But I think the Europeans would have something to say about that. And it was highly recommended in the report last week, the decadal survey that American astronomers get together and produce every 10 years. And it's called Astro 2020. And it should have been released in 2020, but COVID, etc. And it was recommended that Congress step up with the funding for this. So they say it's absolutely essential if the United States is to maintain its position as a leader in ground-based astronomy. So that's all going ahead. Looks like the funding is nearly there. Then, of course, in the later in the decade, we've got the Square Kilometre Array, or SKA. You can read about that by going to skatelescope.org. It's the world's most powerful radio telescope, a square kilometre of both dishes and other antennas split between South Africa and Australia. The goal is eventually to have about 1 million antennae in the array. It's going to be 10,000 times more sensitive than any existing radio telescope, and that includes the giant Chinese fast radio telescope. Just to throw some facts at you, it will be able to detect an airport radar, if such a thing existed, on a planet tens of light years away. It will use enough optical fiber to connect everything together to go twice around the Earth. And the data flowing through those fiber optic cables from the antenna to the receivers will be transferred 100,000 times faster than the average broadband speed for the world. So it's going to be fast. And every year, the SKA would generate enough data to fill 1,500,000 gigabyte laptops. So that's quite amazing. The whole thing's being run by 2 supercomputers, which as of the end of 2019, the design for them is at least as good as the current best supercomputers in the world. And its mission will be it'll be general radio astronomy, but particular focus on the early universe, on the first galaxies and everything else. This will complement the infrared data from the James Webb and the Roman telescope. So we're getting this sort of multi-messenger astronomy, looking at the same targets, but in different wavelengths. So that's quite interesting. It's the world's biggest scientific project ever. And something, I think nearly 500 scientists and engineers are working on it. They've set up, I think, 2 or 3 Pathfinder telescopes that on their own have made remarkable discoveries. So really excited about the Square Kilometre Array. And it should be finally complete in its entirety around 2030. Then we've got the Cherenkov telescope, which is another wavelength. This is a gamma ray telescope, and it's called the Cherenkov Telescope Array, or CTA, expected to see first light in 2025, built in 2 sites, Chile and, believe it or not, La Palma again. So it'll be split between those 2 sites. It's going to be the most sensitive observatory looking at high energy gamma rays. And gamma rays they're emitted by some of the most powerful objects in the universe, such as supermassive black holes and supernovae. And then just to finish off, we've got 2 proposed gravitational wave observatories, which you really can't say are telescopes as such, but they are observatories. Now, we know that we've already got LIGO in 2 sites, at 2 sites in the United States, in Washington State and Louisiana. And we've got the Virgo European Gravitational Wave Detector, which is smaller, but still makes valuable contributions to gravitational wave astronomy when it runs in partnership with LIGO. When they go on the same observing run, the new observing run starts next April, all being well. The Europeans have now said they want to replace Virgo with a gravitational wave observatory called Einstein, which is apt, obviously, being as it was Einstein who predicted the existence of gravitational waves. And this will be a subterranean equilateral triangle housing a total of 6 V-shaped interferometers. And the arms on this will be 10 kilometers long, so 2.5 times the length of the arms at LIGO. And the Americans have come back and they said, well, we're Americans, we do things bigger. And they have come up with a plan for a gravitational wave observatory called the Cosmic Explorer. And this will have 40-kilometer arms. And the longer the arms, the greater the sensitivity and the greater the range. So the current range of LIGO, this is the distance that it can detect gravitational waves from black hole mergers, neutron star collisions, black hole neutron star collisions, etc. LIGO can only see out to about 10 billion light years away. The Cosmic Explorer, say the Americans, has the potential of seeing to the edge of the observable universe, which is 45 billion light years away. And if we could detect gravitational waves from the edge of the observable universe, that would be absolutely amazing. So there you are. That's a quick run through the new generation of space and ground-based telescopes and gravitational wave observatories thrown in for good measure. And they've all got websites, so you can go and check them out. And that's it, basically, Daz.
Yeah, well, of course, in the gravitational waves as well, you got Kagra.
Yes, we got Kagra as well.
That's the Japanese, isn't it? Japanese or Chinese? One of the two.
Yes, it's Japanese.
Japanese. And also, there's the discussion about LISA.
Yes,
which is the space-based
space-based one.
Observatory for gravitational waves, which will be enormous if it comes into being. As regards the Hawaiian fiasco at the moment with the 30 meter. What's the weight? That'd be a waste of time. Yeah, that'd be a waste of time with a telescope. I see no shit.
Lilliput?
But yeah, it's what's happened there is, as you said, it's all to do with Hawaiian tradition and the mountain being considered sacred. And it's not just straightforward as they're fighting against it. It's the fact that the observatory itself, when they built the telescopes, they were allowed to build so many and take up so much room. And the agreement was that before they build any more, they'd have to decommission an old telescope and return the area that it's actually sitting on back to its traditional way, how it was, its natural way.
Right.
And of course, that's not happening. And basically, the Hawaiians see it as basically they're just spreading out. Whereas they should all be, stay within the confines of what they've already got.
Gotcha.
So it's a bit more complicated than it's just being, some Hawaiians being uppity. It's their tradition, and you've got to respect people's tradition.
Absolutely.
And as you said, with La Palma, unfortunately, with the volcano, and it is quite a big disaster for them at the moment.
It is. It's
of course, as you said, the telescopes there are shut at the moment. But it's there's a lot to look forward to, really a hell of a lot to look forward to, especially with the James Webb. Hopefully 18th of December it will be taken to the heavens and on its way, and everything will work wonderfully. Of course it will. And hopefully by sort of like the mid next year we will be seeing some beautiful images made from the data, because as you said, it isn't actually going to be taking photographs like the Hubble, something that you can just slap onto a thing. The data has to be crunched, and then the image is arranged. And it'll be interesting to see what color palette they used. And again, that was something else we discussed last
we
night.
discussed that last night. And the other thing, it's just worth stressing again that the James Webb is an infrared telescope. We're not going to get the glorious optical color images that Hubble has shown us. We'll see infrared pictures, which frankly won't be as impressive visually, but they'll be a hell of a lot more important scientifically. Because infrared is where it's at, basically. That's where the science is. Because when we look back to the early galaxies, for example, their light, which, these were full of young, very hot stars, and they were glowing sort of blue-white. But in the intervening 13-point-something billion years, their light has been redshifted into the infrared wavelength because of the expansion of the universe. So that's where all the important scientific data is in the early universe. It's in the infrared. And if we want to learn about the first generation of galaxies, how they formed, what characteristics they had, how did we suddenly... Now, here's a bit of a cosmic conundrum, because, and this is something the James Webb has the potential of definitely helping us with. So if you look at the current infrared images of early galaxies, and we're looking back to maybe 500-600 million years after the Big Bang, which is the current limit of telescopes, they're sort of formless, amorphous blobs, with no visible structure. And yet suddenly, about 200 million years later, we see the majestic spirals. So the question is, astronomers have long assumed that there has to be some sort of intermediate phase between the blobs that we saw as when the galaxies were very young into the majestic spirals that we see just a few 100 million years later. But no members of that generation, no examples of that generation have ever been found.
No.
And it's, obviously it couldn't have been a sudden transition. You've got a blob 1 minute and a fantastic spiral galaxy the next. So there must be an intermediate stage. So hopefully this is something that the James Webb can help us to understand.
Yeah, mate, because as you said, in the early universe, when we're talking about stars, they were super massive stars.
Super massive.
So they were absolutely ginormous, and they only lasted a few million years.
Yeah, that's right.
Their hydrogen, like nobody's business, trying to keep themselves
like it was going out of fashion.
Exactly. They didn't realize that there was so much around, and they could just wimp along. No, of course, when these things go, they created the first heavier elements, and of course they all went really big supernova, and possibly some of them formed the first black holes as well.
Yes, definitely. And that's another question that the James Webb is going to help us answer. How did supermassive black holes get so hugely massive in the early universe in such an apparently short space of time? Well, short in astronomical standards,
Astronomical,
and not short by our standards. It's not about
not a couple of weeks. There's a lot of things that we need to have a look at and try and suss out what actually went on. As you said, we had the supermassive large stars. They were all doing their thing and going supernova, bigger than anything we've probably ever seen. And it could be one of the reasons why you get these blobby galaxies. But as you said, we have seen no sort of like transition between the two. Just all of a sudden, bang, you've got spiral galaxies. It's one of the things we hope to find out with the James Webb, and if anything's going to do it, it should be the James.
All this data is in the infrared, so that's why it's so important to have a big spaceborne infrared telescope.
Yeah.
Okay, then, Daz, back to you.
Right, that was a good one. Much I like that, because something to look forward to in the future.
There's a lot to look forward to. Don't let anybody ever tell you different.
T is for transients. I'm going back to my time domain.
Okay.
Astronomy. Have you ever heard of something called an F-bot?
An F-bot?
Yeah.
No.
It's a fast blue optical transit.
And
there's only been 3 of them discovered. I'll just read you. I only got this, found this probably about five days ago. And it basically says ultra hot, ultra fast explosion called the Camel has astronomers puzzled. They got quite funny names, actually. This one's called the Camel.
Yes, yes.
Yeah. Only 2 other explosions like this have ever been detected: the cow and the koala. In October 2020, astronomers detected an enormous ancient explosion tearing through a galaxy several billion light years from Earth. The blast appeared to out of nowhere, reached peak brightness within a few days, and then rapidly vanished again within a month, indicating an extreme cosmic event like the formation of a black hole or neutron star had just occurred. Astronomers call sudden, bright blasts like these fast blue optical transients, FBOTs. That's quite nice, FBOTs.
Makes sense.
Named for their extreme blue heat and incredibly rapid evolution. But if you prefer, you can call this one the Camel. That nickname is which is a play on the object's technical name, which is ZTF20A Sigmel. May seem, I don't know, you get camel out of that. It's a maybe unbefitting a blast so fast and powerful, but such is the way of the FBOTs. A similar explosion detected in 2018, roughly 200 million light years from Earth, earned the unlikely name the Cow, the result of a procedural generated scientific name, while another 2020 FBOT was dubbed the Koala, also a play on its technical name. These 3 cuddly wuddly FBOTs are in a class of their own when it comes to stellar explosions. Unlike typical supernova, the epic blasts that occur when stars run out of fuel and collapse in on themselves, FBOTs seem to appear and disappear in a matter of weeks rather than years. But, excuse me. But even after their visible light fades, FBOTs continue to be radiation powerhouses. In a paper published on October the 13th to the preprint database Arctics, astronomers studied the Camel in wavelengths across the electromagnetic spectrum to get a glimpse of some of the invisible carnage playing out after the initial blast. The team found that the initial Camel explosion also shone brightly in radio frequencies, suggesting that the blast was tearing through its cosmic neighborhood extremely quickly, probably a few tenths of the speed of light, more than 100 million miles per hour or 160 million kilometers an hour. The researchers wrote, such bright radio emissions usually come from synchrotron radiation, which occurs when charged particles rocket through a magnetic field at a fraction of the speed of light. Behind the blast, a powerful engine seeved for months. The team found that the blast glowed with X-ray emissions long after its visible light faded. As with the Cow, this stream of X-rays suggests that something powerful, like a black hole or a neutron star, was driving the Camel's intense emissions, the team suggested. It could be that FBOTs represent a rarely seen moment of cosmic creation, blasts that occur the instant an old star implodes, collapsing into a massive black hole or fast-spinning neutron star before our very eyes. Astronomers have never seen these processes actually take place, as far as they know, so it's hard to know for sure what the resulting flood of radiation would look like. But one thing is clear: the cow, the koala, and camel are not your average mammals. There's nothing average about them. So these are very extreme events that obviously happened quite a long time ago.
Yeah.
But we've only just seen them. And like they say, it could be now that we've actually seen black holes being formed when massive stars collapse.
Yeah.
So, but I just thought that, yes, F-bots. I mean, I don't know. It sounds something. I don't know about cuddly wuddly, as they said.
No, I mean, listen, I've ridden a camel in the Sahara, and let me tell you, there's nothing cuddly wuddly about a camel. They are vicious beasts.
Yeah.
And I'll never forget when we went across the Sahara on camels. Firstly, they're laying down, and you have to get on the intensely uncomfortable wooden saddle. And I was quite not expecting how fast a camel can get to its feet. And I nearly went shooting up in the air and only just managed to stay on. But my wife, the same on her camel. And my camel looked at me as if to say, look, mate, it's the middle of the afternoon. It's really hot. I'm really tired with capital K. You're not going to get any trouble from me, so relax. Okay, so my camel goes off plodding into the desert, and then suddenly I hear the thunder of hooves behind me. And my wife passes me doing about 20 miles an hour, and all I could hear was help, because she had got the nervous camel who was really not happy at all to be ridden in the middle of the afternoon. And she just went shooting into the distance, and I thought, what can I do? So I just thought, oh, well, I thought I'll have to get my camel to gallop after her. Now, how do you get a camel to gallop? I tried giddy up, but he didn't understand English, obviously. And I thought, well, I'm not wearing any riding spurs, so I can't really sort of dig my heels into his sides, into his flanks. And I just had to watch her go, luckily not over the horizon, but some distance. So funny. Honestly, but that's by the by. That was just a funny experience.
Yeah. So
eventually, her camel tired, and she when I caught up with her, she was green.
Yeah, I bet she was. Yeah, because they're not the most. They're not called the ships of the desert for nothing.
No, they're indeed. They're more like
have the same effect on.
Yeah, destroyers, dreadnoughts.
Yeah. So that was basically fast blue optical transient F-bots, which are very violent explosions.
And I'm sure that there will be more that will be discovered, and we'll get some clue as to exactly how they
what they are.
But they must have been humongous explosions. It's difficult to comprehend of the size of those explosions.
Exactly, they sound astronomical.
Actually, I must just go back to my list of upcoming telescopes. I wrote all the names of these telescopes down so I wouldn't forget them, and I missed one off my list, which is the biggest telescope ever being built, the European Extremely Large Telescope, currently under construction in the Atacama Desert in Chile, not too far from where the European Southern Observatory has its the majority of its scopes. And this will be the biggest telescope ever built on Earth. It's got a 39-meter mirror comprising an optical system of 5 mirrors in total. The light path is a bit complicated, but they know what they're doing. So the light bounces off this segmented primary mirror, which of course has got actuators behind each segment to automatically deform it in compensation for the twinkling in the atmosphere. So it's going to have the most powerful lasers to create that artificial star high up in the nitrogen zone of the atmosphere, to measure the twinkling of the atmosphere, if you like, and to move the motors on each mirror segment in the opposite direction, basically, so that the telescope won't see the twinkling. It's an immense project, and it's going to see first light now in 2027, they reckon. But it will be the biggest telescope ever built on Earth. Now, the great thing about this is, while people are saying, oh, I can't wait until the James Webb gives us, images like Hubble does, not understanding that it's an infrared telescope, as I said earlier. Well, the European Extremely Large Telescope is an optical telescope, but it's going to give us images that are 15 times the resolution of Hubble, at least. So watch out for those towards the end of this decade, because the images from that telescope, with its incredible light gathering power, is going to be amazing. Originally, it was going to be a 41-meter telescope, but they decided, or they found out, that by just taking one of those horizontal segments from each position around the edge, sorry, not horizontal, hexagonal segments, removing them from a series of them from the edge right round the diameter of the telescope would save them a lot of money, but not impact the image quality that much. So it's come down now to a 39-meter mirror, and it's going to be absolutely amazing. Worth looking up on the internet. Again, they have a fantastic website with some brilliant graphics and lots of wonderful explanations. So that's the European Extremely Large Telescope. So just to add that, because we can't really talk about the next generation of telescopes without mentioning that, obviously, the world's biggest ever. Now, moving on then, my next T is quite a short one. It is, in fact, Telesto. I don't know whether you know Telesto. It's a moon of Saturn. Believe it or not, it's we haven't done moons recently, so I thought
we've been pretty good.
Thought we'd have a few moons today, as it were. It was discovered by 4 astronomers with the surnames of Smith, Reitzemer, Larsen, and Fountain in 1980. So it was quite a late discovery. And it was designated at the time S1980 S13, but the International Astronomical Union accepted the suggested name of Telesto. And we get back to your Greeks again there, Daz, because Telesto was one of the daughters of the Titans, Oceanus and Tethys. And we know that Tethys is also a moon, of course, of Saturn, of Jupiter, Saturn. And in fact, Oceanus and Tethys had 3,000 daughters. They were all water nymphs, and Telesto was one of them. And she was the personification of divine blessing or success. And in fact, Telesto in Greek means success. So the interesting thing about Telesto is that it's in the same orbit as Tethys. And it actually resides in Tethys leading Lagrange point. Okay. So it's in a stable orbit at the Lagrange point around Tethys. And an astronomer called Seidelman and a couple of others found that out in 1981. And there's another moon that is also co-orbiting with Tethys in the trailing Lagrange point, and that one is Calypso. And both of those moons, Telesto and Calypso, lead and trail 60 degrees ahead of and behind Tethys accordingly. And
it's familiar, doesn't it?
It does, yes, absolutely. Yes. So it's the same sort of thing as we have with our Lagrange points. In fact, every planet and object has a Lagrange point where the gravitational attraction of the body and the sun cancel each other out. So putting anything at that point means that it won't be disturbed. It won't be pulled to another place. So that's Telesto. It's interesting because it is a Trojan moon, essentially. It's a Trojan moon with respect to Tethys. So there we are. Very short and sweet. It's not known exactly how big it is, but there you are. So it's designated as Saturn 13. It has another name, actually, apart from Telesto and Saturn 13, is also known as Tethys B, because of this co-orbiting thing that it does with Tethys. So there we are. That's sweet. Telesto for you, moon of Saturn. Yeah,
we haven't done a moon for ages.
No.
Okay, then there's a little diddy one, obviously.
Yes.
These chaps who discovered it, they weren't from Hawaii, were they?
No, they weren't. No.
Oh, that's good.
Well, it doesn't look like it from their names.
They're not having it all the way, because all the other moons and everything else have always been.
I know that team on Hawaii who seem to have the monopoly in discovering moons,
or get a proper job.
No, so, exactly. Okay, right. Over to you then. What's your next one?
Okay then. Right. Bit of sci-fi now. T is for Tatooine. Tatooine. Oh,
that's Star Wars.
Of course. That's Star Wars.
Star Wars,
exactly.
right. We're going to stop recording right now.
I know you love a bit of Star Wars.
Alphabet listeners, thank you so much for listening today. We seem to have strayed into crap sci-fi territory here. I do apologize. Hope you'll forgive us. Go on.
Yeah, I know you. I know you think the Star Wars films are documentaries, and it says basically it's edging on the sort of like thing. But basically, what it is how common are Tatooine worlds?
Right.
Luke Skywalker's home planet is not so sci-fi after all. We all know that iconic scene when Luke Skywalker staring forlornly and perhaps wistfully at the double sunset of his home planet, Tatooine. Long a staple of science fiction, the possibility of habitable planets orbiting a pair of stars has been challenged to solve for astronomers. But a recent analysis has shown that double sunsets may be just as common as in our galaxy as the solitary kind that we know on Earth. And this has big implications for our search for life outside the solar system. A good fraction of the stars in our galaxy are in binary pairs or part of even larger collectives. Upwards of 2/3 of the most massive stars live with a companion, while at the other end of the mass spectrum, only 1/3 of the small red dwarfs find themselves in a pair. But when it comes to finding life beyond Earth, we're most interested in sun-like stars, and for them it's split 50-50, with half flying solo and the other half making friends. So if half the sun-like stars in the galaxy are in pairs, could these systems host Earth-like planets? For some time, it was thought that the complicated gravitational dynamics of multiple stars would prevent the formation of planets in the first place. But we now know that there are two ways a planet to find a stable home with multiple stellar parents. In the first case, if the binary stars are far enough apart, then a planet can orbit one of them safely without any gravitational disturbance from its star sibling. In this case, the other star is far away. It would appear as just as a peculiar bright star in the planet's sky. The other allowable scenario, as if two stars orbit extremely close together, if you place a planet in orbit around the pair at a far enough distance, then all the planet, gravitationally speaking, sees is a single large star and is able to orbit in peace. While we have found exoplanets in both of these configurations, it was previously thought that these setups were rare and special, and we therefore shouldn't bother directing our ET searches at binary stars, instead focusing on more promising, more likely homes for life. But in astronomy, as in all sciences, you can't just run with your assumptions and call it a day. You need to test your ideas against reality. Nature is often much more clever than we realize. In this case, we assumed that planets would have a difficult time forming in binary systems, and so our efforts were best spent elsewhere. Additionally, it's hard to even look for exoplanets in binary systems. The complicated orbital dance of the stars themselves makes it hard to disentangle the faint whispers of influence from the planets. Just spotting a planet around a single star is already a difficult enough task. So in most surveys, the binary star systems we largely skipped over in analysis. So because we haven't looked for planets in binary star systems very often, we haven't really found many. So is this a classic case of observational bias? We didn't look for something, so we didn't find it. And that is until recently, when thanks to Europe's Gaia spacecraft, which has accurately mapped out millions of stars in our galactic neighborhood, a pair of astronomers were able to examine the back catalogue of published exoplanet results in a new paper recently posted to the online preprint site Archivix again. Here's the thing: even though previous exoplanet searches tried to exclude binary systems because they are hard to analyze, and thought to get to not to be promising candidates anyway, they weren't always successful. For a telescope with a given magnification, two stars that are close together will appear as one. In the recent study, the astronomers found that over 300 planetary systems that actually had more than one star, unbeknownst to previous astronomers. And those accidents proved a treasure trove of information, since they give us a ready-made sample of the frequency of planets around multiple star systems. And the main result is this: planets appear no more or less common in binary systems than in solitary ones.
Really? That's interesting.
Yeah. A result at odds with previous conceptions.
Yeah, that surprises me.
It is. It's very surprising. However, there are more wrinkles to the story. If the binary stars are very close together, separated by less than 2.5 astronomical units, then it's highly unlikely to find a planet there, suggesting that close impairs can destabilize the planet formation process. 1 AU, or an astronomical unit, is the average Sun-Earth distance. About 93 million miles or 150 million kilometers. On the other hand, binaries that are moderately far apart between 3 and 6 AU have a uptick in planet hosting ability, implying that they have some special source that favored not inhabited the formation of the planets, or not inhibited the formation of the planets. While this work is still preliminary, it doesn't suggest that we should broaden our exoplanet searches to binary star systems, because they could just be likely to host life as any solitary star. So Tantanine may be a real life possibility for some alien civilization. Yeah, so I think I said it does not. It does suggest that we should broaden our exoplanet.
Yeah,
So Star Wars may have got it right, and it could be a documentary, as I said. So so Tatooine, planets could actually exist where you'll have two suns in the sky at the same time.
I don't understand why everybody made such a big deal about that in Star Wars, because it's obvious. I think it's obvious that there will be planets with, not just two stars in the sky, but multiple. Yeah. I mean, you look at planets at the center of a globular cluster where there may be thousands of suns in the sky.
Exactly. Yeah.
Because the center of an average globular cluster, they're about one every cubic parsec, aren't they? So really close together. And this is why I don't understand why everybody thought it was a revelation in Star Wars that there could be a planet with two suns in the sky. Big deal. It's obvious when you think about it.
But they've been in... Yeah, sorry.
Yeah, go on.
Carry on. No, I was going to say, you often see them depicted in pictures anyway in science.
Yeah, that's right. I mean, if you look at some of the famous space artists like David Hardy, then and people like this, they've been painting them and imagining them for decades and decades. So there you are. But I mean, I wasn't of an age where I could get into Star Wars. I think I was a bit too old for it. I found the whole thing a bit childish in 1977 when it came out. It's fun. Or at least it used to be.
I think that's the way to look at it.
Yeah, I mean, Star Wars was made as a homage to 1930s sci-fi like Flash Gordon, and on that level, it works really well and it's really well done. But people have taken it far too seriously since, and they have these learned beard-stroking conversations about the meaning of it all, when it's just fantasy. There's no science in it. It's not science fiction. It's fantasy. And, in the Star Wars universe, there's no adherence to any physical laws whatsoever. And because of that, it's fantasy. It's in a universe that could never exist and never has existed, even though they claim it was a long time ago, far, far away. That universe has never existed and will never exist. It's, and it's not even consistent with its own laws and things like this. And when you're world building, you've got to be consistent. Yeah. And in Star Wars, they invent things on the spur of it just to help the plot along, which is not convincing. It's true. And all these major scientific mistakes they make every 2 minutes, like, spacecraft in an asteroid field where the asteroids are just a few meters apart instead of being millions of miles apart as they are in reality. And it's fun. It was fun. And I just think they've taken it too far. They're flogging a dead horse. And they should have stopped at Return of the Jedi, because that was, apart from the bloody Ewoks, that was fun. And, it should have been left there. But, where there's a possibility of making money out of crap, I suppose they'll always do it, won't they? Yeah. So there you are. But, no offense to Star Wars fans. No, actually, big offense to Star Wars fans. It's rubbish. But it's not for me. It's not. I prefer science fiction where the science is right, hard sci-fi, so to speak. Anyway, so yes, So
what you're saying, you're sitting on the fence.
Yes, exactly. As always, I'm just sitting on the fence. I don't really have.
No, I can understand what you mean. I mean, I've really never been a Star Wars fan as such. I've probably watched 3 or 4 of the films. But I always get them out of sequence, so I ain't got a clue what's going on anyway.
No.
It's because you had the series, then you had the prequels, which caused a bit of confusion.
And they've all got such stupid names as well. Does the name Thuban mean anything to you? Thuban, Thuban.
I'm going to say no, because it doesn't ring a bell at the precise moment.
Right, call yourself an astronomer. It's Alpha Draconis. It's the brightest star in the constellation of Draco, the dragon. Yes, or Draco.
That was cunning.
Yeah, it was, wasn't it? Yeah, it's located in the tail of the dragon. The dragon in question being between Ursa Major and Ursa Minor, the Big Dipper and the Little Dipper, of course, sandwiched between those two. Why am I mentioning this? Well, it's always our goal on this program, listeners, to tell you something a little bit interesting about these things that we find interesting. What's interesting about this is that 5,000 years ago, Thuban was the pole star.
Oh, okay.
Yeah, just 5,000 years ago, not long. And thanks to precession, this wobbling of the Earth's axis, whereby the Earth is slowing down like a spinning top slowing down, and the top of it is describing a circle in the sky as it goes round, which is about 23,000 years it takes to go round once, if I remember rightly. And 5,000 years ago, this star, Thuban, the brightest star in the constellation of Draco, or Draco, depending how you want to pronounce it in the dragon, that was the pole star. It's a white giant star, so a little bit unusual. And its spectral type is of A0111, if you want to know that. It's about 300 light years away from Earth, an apparent magnitude of 3.7. So in the night sky, it's not actually a bright star, so you'd be forgiven for not noticing it. Draco, is not a bright constellation by any stretch of the imagination. Its absolute magnitude is about 1.1, though. And it's near the North Celestial Pole, because it was 5,000 years ago the pole star. So I thought that was quite interesting. And if you go and find that star and look at the current pole star, which again, Polaris is not a bright star. A lot of people, in my experience, expect the pole star to be a really bright star, some sort of a beacon in the night sky, but it's not. Dull. It's not a bright star at all. If you didn't know it was the pole star, you'd see nothing special about it at all. If you, the way to find it, for those of you who don't know, if you follow the end of the handle of the plow across the sky, the next noticeable star you come to that you can actually see is Polaris, the pole star. And it's some distance from Ursa Major, or the Plough, or the Big Dipper, or King Charles Wain, or whatever you want to call it. And there we are. So that's Thuban, also Alpha Draconis, the brightest star in the constellation of Draco, because stars in a constellation are given Greek letters depending on their brightness, where Alpha is the brightest star. And theoretically, if there are enough stars, Zeta is the faintest star. And there you are. And 5,000 years ago, the ancient Egyptians had that as their pole star.
Oh, excellent. I know about the progression of the
Yeah,
things going.
yeah, the
Um,
position thing. Yeah.
because I can't remember which is the next star in line.
Oh, me
It's one of
neither.
the
Me
yeah,
neither.
it's one of the better known
But
ones.
it does show that how much the Earth is wobbling in its axis over time. If because if you look at the distance between Thuban and um, and the current pole star, which we call Polaris, you can see over 5,000 years how much the Earth has wandered, if you like.
Wandered, yeah, exactly. And
So
as you said, Polaris isn't very, very bright.
no,
In fact, I think we're lucky that we can see it at all, because I think the southern pole star you can't see at all. It's not
no, you
a
can't. You
magnitude.
can't.
Is
Isn't Polaris magnitude 4 point something? I think
something like that. It's very, very dim.
1 second. I'm just going to look that up. I need to confirm that.
I can't
It's not a
remember.
bright star at all.
Yeah.
So you'd be forgiven. So ancient mariners could use it, but it's not a bright star. Oh no, it's not. It's not actually that faint. It's 2.0.
Oh, is it?
Yeah, I thought it was
maybe
fainter than
it's the
that.
light pollution I'm under. I don't know.
Well, actually, I was going to say that because from where I am, we have bad light pollution from the city of Girona to the north, and all the stars in my northern sky appear faint. That's why I couldn't see that comet last year. Damn the city! Completely drowned out by the lights of the city.
I was going to say, burn it down, and you get even more light pollution.
Yeah, that's true. That's true.
Yeah.
So there you are. So back to you then.
Okay, then I'll try and be quick with this one because I think we're running short of time a little bit.
We are. What a show! That's gone quickly, hasn't it?
Yeah. T is for the Tunguska.
Tunguska
event. Also known as the Tunguska. Oh, I could say it earlier on. Incident. It was a massive 12 megaton explosion that occurred near the. I'm not going to go into the name of the river. It's because if I can't say Tunguska,
you can't say it.
Yeah, it's in Russia. It's in Russia.
Tunguska.
Tunguska. I could say it. If I say all the names, we won't have any time at all to it. Well, on the morning of the June the 30th in 1908. The explosion was over the partially populated eastern Siberia taiga, flattened a estimated 80 million trees over an area of 2,150 kilometers squared, which is basically 830 square miles of forest. And eyewitnesses reports suggest that at least 3 people may have died in the event. The explosion is generally attributed to a meteor airburst, the atmospheric explosion of a stony meteoroid about 50 to 60 meters or 160 to 200 feet in size. The meteoroid approached from the east-southeast and likely with a relatively high speed of about 27 kilometers a second. It is classified as an impact event, even though no impact crater has been found. The object is thought to have disintegrated at an altitude of 5 to 10 kilometers or 3 to 6 miles, rather than to have hit the surface. The Tunguska event is the largest impact event on Earth in recorded history, though much larger impacts have occurred in prehistoric times. An explosion of this magnitude would be capable of destroying a large metropolitan area. It has been mentioned numerous times in popular culture and has also inspired real-world discussion of asteroid impact avoidance. So it was a massive event. There were eyewitness reports. And it basically said, as I said, it was on the 30th of June, 1908. Evenki natives of Russian settlers in the hills northwest of Lake Baikal observed a bluish light, nearly as bright as the sun, moving across the sky and leaving a thin trail. Closer to the horizon, there was a flash producing a billowing cloud, followed by a pillar of fire that cast a red light on the landscape. The pillar split in two and faded, turning to black. Then 10 minutes later, there was a sound similar to artillery fire. Eyewitnesses closer to the explosion reported that the source of the sound moved from the east to the south of them. The sounds were accompanied by a shockwave that knocked people off their feet and broke windows hundreds of kilometers away. The explosion registered on seismic stations across Eurasia, and airwaves from the blast were detected in Germany, Denmark, Croatia, and the United Kingdom, and as far away as Latvia, Dutch East Indies, and Washington, D.C. It is estimated that in some places the resulting shockwave was equivalent to an earthquake measuring 5.0 on the Richter magnitude scale. Over the next few days, the skies in Asia and Europe were aglow. There were contemporaneous reports of highly lit photographs being successfully taken at midnight without the aid of flash bulbs in Sweden and Scotland. And it sort of goes on. There are lots of eyewitness reports if you go online and look up the Tunguska events. There are from the actual tribesmen who are actually, and some of them are quite shocking, really.
Yeah.
Some of them were buried in their cabins and things like that. There's been several, as regards, I know there's been several expeditions to try and go and
they've been trying to find the impact site, but
impact crater, and
there's nothing.
Yeah, I've seen pictures of these people going in, and all you can see is they're absolutely smothered in a fog of mosquitoes. It must have been
that was the worst thing, because the first expedition didn't arrive there till 1927. Yeah, and they decided they really didn't want to stay there that long because they were being bitten alive by countless mosquitoes.
Yeah, I've seen the film, and it's absolutely horrendous for them. And as I said, there's been several expeditions. They haven't found a crater as such, although a small lake has possibly been called Checo.
Yeah, I think that's been disproved now. I think they proved that it was there before the blast, if I remember rightly.
Yeah, it's just a very small crater. There's also a hypothesis that it was a glancing impact of an asteroid that passed through the atmosphere, but then passed out the other side. And
that's right. That's a Russian idea, because they say that if you work out how many miles through the sky it traveled if it was a descending meteor or asteroid or comet, it didn't travel that far through the sky. It didn't travel as fast as it should have done. In other words, there's a good possibility it bounced back into space, and the blast was caused by high density plasma being pushed ahead of the object, which they're postulating was actually an iron asteroid with a high density.
Iron asteroid,
yeah, that's right.
Yeah, and it's gone back into solar orbit.
Yeah,
but that's sort of like been not discounted, but they said with the actual explosion and how it acted, it was more likely an explosion in the sky. It has also been thought there's a debate whether it was an asteroid or a comet. There's even been talk about that it could have been a UFO.
Yeah, we'll forget that.
But we'll forget about that one, shall we?
Yeah.
And yes, it was Lake Chico that was possibly identified as the impact crater that was left. But it was whatever it was a totally near miss.
And I don't think we'll ever know exactly what it was.
No, without actually finding debris or anything like that. And in the area, I mean, it's virtually grown again, but you can see the pictures. Everyone's seen the pictures of literally swathes and miles of trees that have been knocked flat. And
right.
You can see, and it does form a big circle.
Absolutely.
So that is the Tunguska event, which was an airburst in Russia
in 1908. Indeed,
1908. Yeah.
Right. Well, thank you very much. And just 108 years later, of course, we had the Chelyabinsk event, which was a big piece of rock. that exploded above the Russian city of Chelyabinsk, and about the size of a double-decker bus, and it injured 1,000 people, mainly flying glass when windows
flying
shattered.
glass, because they were all sat there watching it.
Yeah, absolutely. There you are. Right then, dear listeners, that brings us to the end of another edition of the Amazing Astronomical Alphabet. Hope you've enjoyed it. Thank you so much for listening. We do appreciate it. And next week, Daz, we have a few decisions to make, do we not?
Yeah. Yes, we're going to struggle with the next few,
because we now hit UV, W, X, Y, and Z, and that is going to be difficult to provide enough interesting things for you with those letters. So we're discussing what we're going to do. We'll probably end up amalgamating a few of the letters into one edition, but we'll let you know. It might help
also with the music as well.
Yes, with the weekly listeners quiz to identify the artists beginning with the week's letter. And, I can only think of 2 bands beginning with the letter U, and that's U2, Ultravox, the Undertones, I guess. Yeah. But there aren't many. Yeah. So we'll have discussions this week, and we'll let you know what we've done next week. So until next week, take care of yourself, stay safe, and any final words, Daz?
No, exactly. Just everybody, please take care. It's still a jungle out there, and look after one another, and we'll see you again next week. Yeah, be careful out there in the COVID jungle, and look after yourselves. Have a fantastic week, and we'll speak to you next week. Bye-bye. Bye.